In this practice lab, I'm going to be looking at how switch operates, how it forwards frames between different devices. In the previous video, we took a look at the communication between two PCs using Wireshark, and we determined that initially, in order for computers to communicate, or any device to communicate across the network, they need to know their MAC addresses. Now, we looked at the situation where both sender and receiver were in the same layer 3 subnets. More on subnets and addressing scheme in IP later, but for now, any communication that is sent across the wire or wireless network needs the MAC address of a sender and the receiver. And in order for computers or devices to learn the recipient's MAC address, the ARP request was sent. We discussed that in the previous video. Now, what we saw that the Ethernet frame header has three fields. There's a source MAC address, destination MAC address, and there's also information as to what is encapsulated inside this frame. Today, I'm going to be looking in my lab at a communication between the PC1 and PC2. So the PC1 obviously has some IP address, and it is 10.1.1.101. The PC2 has 102. All ports of the switch 1 here belong to the same VLAN. Virtual LAN is another topic for another day. We'll talk about that as well. But for now, they are all in the same broadcast domain. So that means that each computer sending broadcast information will be sent across all those ports listed in this diagram. So how does it work? So when PC1 wants to communicate with PC2, for example, if I want to send a ping packet, which is the ICMP layer 3 message, hello, and this generates the packet will be at the layer 3 sourced from 10.1.101, destination will be 10.1.1.2. The way we do it in the lab, we just let's go to the lab, and if I go to PC1, I'll just say ping 10.1.1.102. That's how I generate a ping packet on a Cisco router. Remember, my PCs are actually routers converted to a role of a PC, which is explained in one of the previous videos. Now, so when I hit enter, what's going to happen is that the layer 3 ICMP message will be encapsulated in IP packets, and the header will have source IP 10.1.1.102. The destination will be 10.1.1.102. If the PC1, let's go to show interface E00. Now that's a big output here, so I can abbreviate that. If I want to just see the MAC address, it's signified with BIA word. So what I can do real quick here, so this is my MAC address. It ends with 0700. Now in Cisco iOS I can do the same command, space, pipe, and there's a bunch of keywords. I can begin with certain keyword, I can include certain keyword, or use the section of the configuration. In this context, I'll say include, I'll abbreviate that to INC, and BIA. If I say BIA, it'll only extract from that previous output the line which has the BIA in it, and that is the MAC address of a sender here. Now, if I'm sending ping packets, this PC1 needs to know what the MAC address of 102 is. If it doesn't, it's gonna generate ARP request broadcast with a source of this highlighted address and destination all Fs. Let's check if PC1 knows what the MAC address of 10.1.1.102 is. On the router, it's show IP ARP command, and it doesn't know what that is. So let's actually, this is the lab, so I can do anything without any damage. So I'm gonna do debug ARP. I want to see the ARP being sent from that PC1 towards PC2 first. So in that case, what's going to happen? The PC1 is going to send ARP request, which looks like this in Wireshark, with the exception that the source MAC address will be the router 1, or PC1 I should say, sorry, and the destination will be all Fs. And that broadcast, let's go back to the diagram, will be sent to this port. What the switch is going to do at that point, it's going to read the frame, and it's going to read the source MAC address and assign it to port EASY12. It'll remember, and that storage place is called content addressable memory, or more often referred to as MAC address table. Once the source MAC address is learned from the incoming frame, the switch is going to look at the destination, and destination is broadcast. So because the PC1 does not know what the MAC address of PC22 is, clearly in ARP cache there is no information, only knows itself, the switch is going to react to the broadcast in the following way. It is going to identify all the interfaces here that belong to the same VLAN, and all of them are VLAN 1 by default, and it's going to forward a frame, the broadcast query, out of all ports that belong in the same VLAN as the sender, which is VLAN 1 here. So up here, the router is going to ignore that because it says, oh, I am not 10.1.1.102. The question was, who's 10.1.1.102? Give me your MAC. But the frame is going to be sent down here, and PC2 will realize, oh, that is my IP address, and somebody, the MAC address of the PC1, is asking what the MAC address of that address is. What it is going to do is going to prepare the reply. Like we saw yesterday, my Raspberry Pi was sending a reply, and the reply comes as a unicast, which means one-to-one communication, and the response would be, hey, I am whatever MAC. In this context, it will be 10.1.102. This is my MAC address, and sending information to the device that asked the question. So if that is the case, the frame is going to be sent the reply, ARP reply, up to here. The switch is going to read the source MAC address, which is the PC2 MAC address, associate or store it in the MAC address table on the port E13, and the frame already knows what the MAC address destination is. It's associated with port E12, so that the frame will be sent directly from E13 to E12 as the switch knows where the recipient is. So switch deals with situations like broadcast or unknown unicast. If switch does not know where the destination MAC address is, in the same manner, it'll forward this out of all ports that belong to the same VLAN as the sender. Now, let's see that on a command line interface. So if that's happening, so I'm going to send a pin packet, in fact, now. I'll see the broadcast because I'm doing debug ARP, so I'll see that broadcast sent. I'll send ping 10.1.1.102. Okay. How do I disable debug? It's you all. See, this is why it's very dangerous to do this on the production system. That could actually crash the box. But this is the lab. So ARP request was sent, and it looks like this. ARP sent from 10.1.101 with this MAC address. Destination is 102, and we don't know what that MAC address is. Now, here the system sends the ARP request and doesn't get any ARP reply. It sends a bunch of ARP requests. So let's see what happens. Why didn't we get the reply? If I ping, so right now, actually, in fact, if I do ping 10.1.1.102, it's going to be a troubleshooting session at the same time. Debug is still on. I'm sending ARP requests. I'm not getting any reply. You all. So you disable this debug by sending you all, and you have to be fast. This is the reason why you don't use debugs on the production system. It's hard to disable. So you all, and what I'm going to say now, let's do ping again. There is no reply. Reason being is because PC102 did not respond. But why did it not respond? Let's do the troubleshooting. So I'm going to stop this, and I'm going to say show ARP here, and we see that information. We sent a request for ARP request, and we didn't get the ARP reply. It's incomplete. So the quick verification, there could be many reasons. The first thing I'm going to do is, because that's my suspicion, is that the PC2 that does not have IP address configured properly on it. Let's see that. So if I jump to PC2 and I do show running config interface E00, what I see is that it is a completely wrong IP address on the device. So upon query, who has 10.1.1.102, nobody responded because no one has this IP address. Quick fix interface. So in fact, I'm going to enable here debug again. ARP. I'm going to go back and correct that. Interface E00 IP address should read 10.1.1.102 with 255.255.255.0 and no it's already up and running. So now if I send the ARP request, if I send the ping packet again, watch what happens. Now it's success, you all. It is success. First was lost on ARP request, ARP reply, the remaining packets went through. So upon query, who's got the destination 102, tell me your MAC address, we got the reply, and that reply is basically here. You received the reply from the 102 and it told us its MAC address. Now it's map show ARP in ARP cache, and we know how to reach that. So what happens also in the background, like we said previously, we learn the source MAC address of this guy and associate in the content addressable memory with port E12. Let's see that now. So MAC address of the device, wrong window. MAC address of a device R1 show interface E00. Now we know include BIA. This is the MAC address. Let's copy that. It should be associated with port E12 on a switch 1. Let's see that. Switch 1. Now, how do we ask about that? Show MAC address. There's two ways. Either it's going to be show MAC address -address table, or more likely in the newer devices, show MAC address -table. And let's go dynamic. So if I have this E12 port, let's go back here so we can see better. E12, which is this port, we can actually ask specifically for that port. Interface E12, and I copy and paste. That is the MAC address that we learned on port 12. Similarly, we should learn from the response sent by PC2 its source MAC address and associate that with port 13. Let's copy that MAC address now from PC2. We'll do the same command, show interface E00 include BIA. It's 800 at the end. Let's copy that. Go back to the switch and show MAC address 13. It should be 800. And 800 it is. This is the MAC address I just pasted in. From now on, that information is stored for at least 5 minutes by default. If the computers communicate still a bit within 5-minute time frame, it'll be refreshed. If, however, computers don't talk within 5-minute time frame, the MAC address is basically purged from the port and relearned when the computer talks again. And that's how the switch basic operation looks like on the command line interface.